Hello students, welcome to my channel Be Methaholic. Now in this video I am going to tell you about chapter 1 from standard 11, set theory, or in general we can call it as sets. So without wasting time, let us first study what is the meaning of this sets. So to begin with, let us study about and let us see what the sets, the definition of set is actually. So the definition of sets says a set is a well-defined collection of objects. Now we have to focus upon this line, that is the definition. We have to understand the definition here. A set is a well-defined collection of objects. Now before I tell you what is the meaning of well-defined collection, let me tell you one more part of it, that is mathematical statement. Now here I am going to focus upon what is the meaning of this mathematical statement. Actually, what are mathematical statements? So mathematical statements are those statements which are universally accepted by all. Please understand, इसको बहुत सिंपल लैंग्वेज में हम इस तरह से कह सकते हैं कि ऐसे सेंटेंसेस जो पूरे यूनिवर्स में एक्सेप्ट हो, जो हर लोग जिसको एक्सेप्ट करें, वही सेंटेंसेस क्या कहलाते हैं? मैथमेटिकल स्टेटमेंट्स. सो दोज सेंटेंसेस विच आर एक्सेप्टेड यूनिवर्सली आर कॉल्ड एज मैथमेटिकल स्टेटमेंट. So here we will only talk about those mathematical statements which are not ambiguous. Ambiguous means which does not have a common consensus. तो हम ऐसे sentences लेंगे जिनका common consensus हो, जिस पर एक राय बने सारे दुनिया की, वही sentences की बात करेंगे. So those sentences are called as mathematical statement. So let's begin with here again. I come back to the definition. So let us see it. A set is a well-defined collection of objects. Now what do you mean by well-defined? Well-defined means, here I'll explain it through these two examples. So for this I have taken two statements. To understand this, let us talk about statement 1, which says, this is a sentence, in fact I should call it a sentence right now, a collection of honest people in our country. Now here, for some you may call it, in fact you can take it, why to go to our country, in fact you can take it in your neighborhood or in your class only, students, that you cannot define a person who is honest or who is dishonest. So there may be अलग अलग राय हो सकती है काफ़ी लोगों की. So this statement, such sentences cannot be called as mathematically accepted statements. So we will reject this type of statements. Or you can say, you can take other examples also, like number of renowned politicians in our country. So for some politician may be his or her favorite, some may not like them. So these are all ambiguous statements. We should not be considering them as mathematically accepted statements. The second one would be a collection of months of the year. Now this is one example I have taken. Now all of you very well know that we can have a collection of months of the year. For example, you can say, if I ask you what all months are there, you can say January, February, March, April till December. We can have the collection of months. That is, we all know that till December we have 12 months in a year. So these are all well defined and accepted by all. So such type of sentences can be called as a mathematical statement. So in this very chapter we will be discussing about different types of such examples. Now we are talking about maths, so of course we will talk about some of the mathematical statements only. Most of the mathematical statements will be dealt here. So for example, a set of, we can say a collection, or you can say a set of first 5 natural numbers. This is one example I am taking, a collection of first 5 natural numbers. Now here the collection of first 5 natural numbers, all of you know what natural numbers are. So I can say like 1, 2, 3, 4, 5 will be the answer. So you can very well answer that these are 5. There are 5 numbers which depicts the natural numbers. So we can have a collection of those numbers. I hope I am clear with the definition. So now the next thing which we are going to discuss is the notations used to define the or will be used in this chapter. So these all notations I am going to tell you what all notations will be discussed. So we begin with the letter, we begin with here the letter N. It says, this is capital N. So this letter is used to describe a set of natural numbers. Wherever you will find, now here we will be only discussing in terms of the letters and these notations. So n denotes the set of natural numbers. Here W, you will find it defines the set of whole numbers. Then we have Q, which shows the set of rational numbers. All of you must be knowing what these numbers are actually. And then we come to the letter Z, which defines the set of integers. Now comes the letter R. It defines the set of real numbers. So in the books, if you happen to see such symbols, you definitely will you should understand it, that what Q denotes. Q is denoting a rational number, Z is denoting set of integers, R is denoting real numbers. Now here this R, now here if you see, we talk about integers or rational numbers or real numbers. These numbers can be positive and they can be negative as well. So if you see Q plus, then this denotes the set of positive rational numbers. Similarly, Z plus denotes the set of positive integers. Likewise, R plus denotes the set of positive real numbers. So I hope I am clear. So as soon as we will be moving to the next set of questions and description of the other topics in the chapter, I will keep telling you what all notations will be used further. Along with this, I am also supposed to describe and tell you about the further Greek letters, some Greek letters and some notations which are also used in this chapter. I begin with the letter epsilon. Now this is a Greek letter. It is called as epsilon, E-P-S-I-L-O-N. The meaning of this letter is belongs to. Similarly, if I write a letter epsilon and I cross this letter, this tells us does not belongs to. Like we used to write equal to and is not equal to, हम लिखते हैं इस तरह से equal to and not equal to, इसी तरह यहाँ पर belongs to and does not belongs to. Similarly, there are two symbols which are used for same purpose. This is colon, you can find on your keyboards only. This is a colon and this is a small short line. Both these symbols are used for one thing, to denote one thing, which is known as and read as such that. Similarly, there is another letter you may find in some books as this, in this manner or in this manner, it's same. It is known as for all. You can read it as for all. जैसे V को उल्टा कर दिया, इस तरह से क्रॉस किया है, तो आप इसको कहेंगे for all. Similarly, we will come across the symbol, this symbol, it is known as there exist. So I hope till here I have shown you a few notations which will be used to describe certain expressions, mathematical expressions in this very chapter. So as soon as we move further, I am going to tell you the use of these symbols. So the next thing which I am going to tell you is representation of sets. Now how you are going to represent the set? So there are certain rules which you have to remember and describe. The first thing which you have to take care of is the sets are always represented with the capital letters of English alphabets. You can use any letter to describe and define a particular set. Second, all the objects or the collection which you have taken are to be represented in terms of curly brackets separated by comma. So this is very important here when you will talk about sets and the collections. The objects which you have collected should be put inside a curly bracket and they should be named with the capital letter of English alphabet. So please remember this side, this part. The third thing, I think I should take one example to represent this. For example, if I take the collection of vowels in English alphabet. Now all of you must be knowing what all vowels are there in English alphabets. They are A, E, I, O and U. So here we will be representing this collection in terms of curly bracket, and all the letters will be separated by comma and written like this. It should be written like this. I hope I am clear in this. We can take another example here. Like if I say a collection of first 5 natural numbers. Now all of you are aware of what natural numbers are. I hope so. You all must be knowing the number systems. So here the collection can be represented as 1, 2, 3, 4 and 5. So this is how you are supposed to write. Now again there has to be some name given to each and everything. So here also whatever objects or whatever collection you have defined in this set form, each object has been given a name and each object is called as element. Please remember this. यहाँ पर हर ऑब्जेक्ट को हम क्या नाम देंगे? We call them elements. Okay. So here A is an element, E is an element. So all these are called elements also, right? So now next thing would be making use of the symbols what we have learned in our previous text. Like I would go with this. Here I have told you what is the meaning of this Greek letter. It is belongs to and does not belongs to. Now where these letters are to be applied, so let us talk about this. So I'm going to take another page and explain it to you. So if suppose I take the example of the vowels only, so if I have the vowel A, E, I, O and U, and if I give you, like if I say in terms of fill in the blanks, if it comes to you and it's been written like this, or D blank A. Now what should be the answer? You must be knowing, I had told you the meaning of this letter epsilon. Epsilon shows, and it is the meaning of epsilon is belongs to. So whether this particular element belongs to the set or not, accordingly you will be filling these two symbols, right? So here since letter A is an element of this set A, so the symbol will be belongs to. So you will be reading it as A belongs to set A. Is there letter B in this? No, you cannot find letter B in this given example. So the symbol used will be this. So B does not belongs to A. Similarly E, if I talk about, E is very much there in set A. So you will be using the symbol belongs to, and D is not there. So you will be using the symbol does not belongs to. So I hope I am clear with this example very much, that how you are supposed to use these symbols by looking at the elements given in a particular set. Now this is very important. Another important thing is, if suppose I have to mention some words in the set form. Suppose I take the word school or the word follow or the word monsoon. How am I supposed to represent this in a set form? Please remember one thing, this is a rule again, that whenever you are supposed to mention any in the set form, any of the words or any of the numbers, suppose you have this numbers also given. So all these are different examples I have taken. I am going to tell you how to represent such numbers or words in terms of sets. So please remember the rule that whenever you have repetitive letters in any of the words or repetitive numbers given, these are to be written down only once. So I'll write it out like this: A equals to S, C, H, O and L. Only these letters will be put in the curly brackets. No repetition of letter should be noted down in the set form. I hope I am clear with this. Similarly, for let's take the word follow. Here O is repeating, L is also repeating. So you will be writing it as F, O, L and W. Please remember the way I am writing. C equals to, now I think you can make it your own, and I might I wish I could hear you answering this. This is M, O, N, S, that's it. Now here you can see N is repeating twice, O is repeating, coming 3 times, and so the letters remaining will be M, O, N and S. So there are only 4 letters which are to be put in a set form, not all the letters. Remember this thing. Again, let's come to this. So the next set would be, this one is repeating twice, so write it only once, then 2, then 3 is coming twice, so make it once only, write it, now comes 4, and then 5. This is how you are going to represent the elements in set form. I hope I am clear with all the rules here. Now if you want to recall it, you can move to the, or you can repeat the, looking at the video, see the video again if you haven't understood it. But I hope I am very much clear in my explanation here, and you all must have understood it. The next thing, next important part is knowing what is cardinal number. Now this is an essential part of this chapter, so you have to understand it. What are cardinal numbers? So I am going to explain you what cardinal numbers are. So cardinal numbers, before that let me take one example of writing it like this. Suppose I take number 3, 4, 7. This is the elements are written in a set A showing elements 1, 2, 3, 4, 7. Now cardinal number is not is nothing but a number which is showing the, which is representing the number of elements present in a particular set, like, and this is represented with small n. And if you are being asked find NA, what does this mean? This means that the number of elements present in a particular set should be the answer. That is, if I say NA, then you just count the number of elements 1, 2, 3, 4 and 5. So NA will be equal to 5. I hope I am clear. I take one more example to explain this. 1, A, C, D, E, if it is there. Alright. So what is NB? NB will be again 1, 2, 3, 4, 5. So just count the number of elements and the answer would be 5. So this is what is cardinal number, which will be helpful in the forthcoming topics you will study in this chapter. So remember this number. Alright. Okay. Now we come to the essential part of it. That is the main part where the representation is to be discussed and shown in this chapter. So the thing we will be here, the representation has 2 forms of representation. You can say in this roster or tabular form. These are 2 forms in which we can represent the sets, roster or tabular form. And the second one will be set builder form. Set builder form. Now what is this roster form? Roster form or tabular form is one and the same word, and this is set builder form. Now see the property of roster form. Roster form says, just now I have taken one example in front of you, that the set of first 5 natural numbers. Now when elements are written and described in this particular manner, separated by commas, then such representation is called as the tabular form or roster form. Another example we had seen just now is representing the vowels. I have represented the vowels in this form. This is also called as the roster form. Second, we also had discussed writing the word letters in the form of set of the word school, SCHOL. So this is again called as the roster form. So please remember this such type of forms where the elements are actually put in this format are known as roster or tabular form. Next comes the set builder form. Set builder form is a parallel form of this, and here we will be explaining the property of a particular thing in a different manner. Now what different manner it is, or in a sentence form you will be writing this. Say suppose I take this example, that this is representing the vowels in English alphabet. So the representation in set builder form will be taken with the symbols which we had discussed. Okay, so let X be any letter which we do not know. So let X is such that I am putting this colon, either you put the colon or you put a small straight line, it's one and the same thing. So X is such that X is a letter, X is a vowel, I beg your pardon, X is a vowel in English alphabet. इसको हम इस तरह से लिखेंगे. When you are writing something in this form, such type of form is known as the set builder form. All right. Like if I say I'm supposed to write, I take one more example to represent this. Suppose I take, now this is one example, I'm bound to take this so that you understand it very easily. Suppose I have one set which is representing elements in this form: 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5 and 5 upon 6. Now all of you must look into the property of the elements as to in what form the elements are given here, okay? Because you will be asked in your questions that convert the set builder form into roster form or roster form into set builder form. So you must very well know how to write in both the forms a particular example. Fine. So what you can see now, see the property of this might be a typical thing for you, but I can explain it very nicely. You can understand it like this, that here this is 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6. Now what does this shows? This shows here that denominator is 1 greater than numerator. Again, this is denominator is 1 greater than numerator. All these numbers are there and this number varies till 5. Okay, so the set builder form of this can be written as X is such that, I have now put the small line over here. This is again representing the same, that is such that. So either you put colon or a small line. So this represents this is representing, so you will be writing it as X is such that X equals to n upon n plus 1. Now why I am writing this, please remember n is any number which I am taking. Now what number, until what number it is going. Now this is not going till end, it is there are finite, in fact countable elements are there. So here you can represent that these are all positive numbers and the maximum number that is occurring is 5. As you can see, denominator is greater than numerator. So if n is the numerator, then denominator will be always n plus 1. So here you have to represent the condition also, that n is varying from 1 to 5. Please understand this part. Here this inequality says n is greater than or equal to 1 and lesser than or equal to 5. This shows that when you are going to put, starting from 1, if you are going to put 1 here, this will become 1 plus 1, 2. So you will have the first element. Then if you will put 2, this is 2 upon 2 plus 1, that is 2 upon 3. Then 3, 3 upon 4, then 4, it is 4 upon 5, and then 5 if you will put, it becomes 5 plus 1, 6. So till from 1 to 5, all the elements are being represented in this. So this type of notation will be considered as the notation form in set builder form. I hope I am clear with this now. Okay, so this is the various representation of sets. So the forms in which you can represent the sets will be roster forms and tabular forms, and set builder form is another form. Okay, so roster and tabular is one form, second is set builder form. So looking into all the aspects of mathematics and looking deeply into the things or the roster form which is given to you, I am taking one more example so that you will understand it nicely. The conversion in set builder form matters a lot. So if I take take these examples 2, 4, 6, 8, 10 and 12, and I can take 14 also, it doesn't matter. So here you can see, now what do you observe by looking at these elements in roster form? What you observe is that there are all even numbers, okay, and they are all even numbers differing by 2 or multiple of 2, you can say in general. So the representation will be X is such that X equals to 2n, and here what is n? You have to represent n, either you show it by inequality or you can say it as for all n belongs to n. What does this means? That small n is comprising of all natural numbers. So, and there is a condition now, since it is restricted till here, so that means what if I am going to put n as a natural number, if I am going to put n as 1, you will get 2. If I am putting n as 2, it is coming 4, 3 रख के 6 आएगा, 4 रख के 8 आएगा, 5 रख के 10 आएगा, 6 रख के 12 आएगा और 7 रखते ही 12 आएगा. मतलब 1 से 7 तक जब हम n की वैल्यूज रखेंगे तो हमें ये सारे एलिमेंट्स मिलेंगे. तो आप यहाँ पर रेस्ट्रिक्शन में शो कर सकते हैं where x is, or you can say the value here of n will vary from 1 till 7. So this is how you have to represent all the elements, and this is another form which is known as, now this form is known as the set roster or tabular form, and this type of similar form which is representing one and the same form, it is known as the set builder form. So I hope I am clear with this. So please go through NCERT exercise. I am going to discuss NCERT exercise also in my future videos, forthcoming videos. So NCERT exercise 1.1 can be done with the help of learning from this video. So happy learning, enjoy, like, share and subscribe the channel Be Mathaholic, and give your comments if possible. Thank you so much.